Welcome viewers. So in this lecture series we will go through the course BSC103 Mathematics I under AICTE and which is similar to the course BSM102 Mathematics I under Maulana Abul Kalam Azad University of Technology in West Bengal. So if we observe the syllabus, it has 5 different modules which covers different topics of differential and integral calculus and few topics from matrix theory. The first module revolves around integral calculus and covers 4 different topics. The second module revolves around some important or fundamental results of differential calculus, which are basically mean value theorems. Then the module 3 revolves around few topics from real analysis, which are explicitly sequence and series. And then we have Fourier series and Parseval's theorem. Then the module 4 contains the concept of limit, continuity, partial and directional derivatives. These topics of function of more than one variable. And the fifth, that is the last module, give us a overview over different properties of matrices. So in today's lecture we will start our first topic, that is evolutes and involutes of the first module, that is module 1. So before going into the concept of what evolute and involute is, we need the concept of what is curvature of a curve. So let us start with that. So what is curvature? So a nature of a curve which measures bending at a point on the curve, that is the rate of change of direction of a curve with respect to arc wall distance. So before going into the analytical expression of how to find curvature of a curve, let us give a brief discussion over what we mean by bending and how to measure it. So suppose we have two curves PQ and P dash Q dash, and for the time being assume that these two curves are arc of the concentric circle centered at O. Now if I ask you the question that among these two curves PQ and P dash Q dash, which is more bended, what will be the answer? Think a little bit. Yes. So I think you have guessed it right, that the curve PQ is more bended. Why? Because see, by rate of change of direction, what do we mean? By direction of a curve, we mean the direction of the tangent in the increasing arc wall length direction. So at the point P, assume that this is the tangent, and at the point Q assume that this is the tangent, and similarly at point P dash suppose this is the tangent, and then point Q dash suppose this is the tangent. Okay, now see, as we have assumed that PQ and P dash Q dash are arc of the concentric circle centered at O, that means by default call this point to be C and this point to be C dash. So by default OP will be perpendicular to PC and OQ will be perpendicular to CQ, and similarly OP dash and OQ dash will be perpendicular to C dash P dash and C dash Q dash respectively, as we have assumed that these are portion of the concentric circle centered at O, and we know that radius of a circle is always perpendicular to the tangent. Now if this angle is theta, angle PCQ, then what we can assert that the angle POQ will be also theta, because we know that angle between the perpendicular to two lines is same as the angle among them. Here we are talking about the say acute angle, so this angle is theta, and by the same virtue angle Q dash, C dash, P dash, this will be also theta. Now see, this theta is nothing but change of direction of the curve from P to Q. Why? Because the direction are direction of the tangent. Now if CP and CQ makes angles with positive axis, then their difference will be theta, and similar for the angles made by C dash, P dash and Q dash, C dash with positive x-axis, their difference will be also theta. So see, in PQ, to produce the same change of direction we have to cover less distance, while in P dash, Q dash we have to cover more distance. That means rate of change is more in case of PQ. So the curvature which is a measure of bending, it should be more for the curve PQ than P dash, Q dash. While we observe that in this case the arc wall distance PQ, this will be OP times theta if theta is measured in radian, and similarly the arc wall distance P dash, Q dash, it will be OP dash times theta. So see, the rate of change which we generally measured by theta divided by arc wall distance PQ, this is on by the radius OP, and similarly here theta by P dash, Q dash, this will be on by OP dash, right? That means the curvature is, there is a inverse relation being among the curvature of a curve and radius of the circle of which a part is the curve. So now with this discussion we will go to the formal analytical definition of curvature. So for that consider figure 1.2. So in this figure assume that we have the curve FP Q, and Q is a point which is very close to the point P, and assume the coordinate of P as S and psi. That means its arc wall distance from the fixed point F is S, and it tangent at P makes angle psi with the positive x-axis, and similarly and coordinate of Q is S plus delta S and psi plus delta psi. Okay. Then how to measure this curvature? What we want to mean by curvature is that although the given curve may not be a circle, if Q is very close enough to P, then the segment PQ of the curve we can think it of as a portion of a circle. That small enough portion PQ of that curve we can think it of as a portion of a circle, and we call that circle to be circle of curvature and radius of that circle to be radius of curvature. Now see, whatever will be the circle of which a part is the small portion PQ of the curve, the center of that circle will lie on the normal line at P. So that's why we have drawn the normal at P. And similarly, if the center will also lie on the normal line at Q, because we are assuming that this small curved segment PQ is a part of that circle, right? So from here we will find out the formula for curvature. Now see, as Q approaches to P, the normal at Q which intersects the normal at P at the point C dash, it will approach to a fixed point on the normal line at P and assume that the point is C. Then CP will be nothing but radius of curvature at P. Okay. And what is curvature in this case? Curvature is limit Q approaches to P, rate of change of direction. So the change of direction in this case is delta psi, and the arc wall distance is delta S, which is arc wall distance PQ. Okay. Now see, from the triangle C dash PQ, what we can write? As Q approaches to P, we have C dash P into delta psi is equal to PQ, which is delta S. Imply limit Q approaches to P, C dash P, it will be limit Q approaches to P delta S by delta psi. Now as Q approaches to P, this C dash P will be Cp, which we call radius of curvature and denote it by rho, and now this will be ds by d psi. Okay, and from here we can write that d psi ds, which was nothing but limit Q approaches to P delta psi delta S, which is our curvature, and this is nothing but curvature, and this is reciprocal of 1 by Cp, where Cp is radius of curvature. So I think the idea of curvature and radius of curvature is clear. So what we actually do here, whatever is the curve, we consider a very small portion. For a point on the curve, we consider a very small portion around P, and we found out that of which circle this is the part. So radius of that circle will be radius of curvature, and reciprocal of that radius will be curvature at the point P. So this is the central idea of curvature and radius of curvature.